Hi, I'm Mr. Meyer. This video is on density. There are three components or two components that make up density. One is mass, which is the amount of matter. And common metric units for that are grams or kilograms or milligrams. English units would be pounds, ounces, or for big items, tons. The other one is volume, the amount of space an object takes up. And we commonly use liters, milliliters, cubic centimeters. In chemistry, a milliliter, a cubic centimeter are the same thing. It's also the same as a cc, which would be cubic centimeter. A final one, some volumes in the English system are quarts and gallons and so on. Density is a mass over volume ratio. So you could have grams per milliliter, grams per cubic centimeter, or any mass over any volume. Let's take a look at calculations here and how to solve these. Typically, you could look at M for mass, V for volume, D for density. Typically in these problems, you know 2 out of the 3 things, and you just have to solve for the unknown. So looking at this, find the density of a material given that a 5.03 gram sample occupies 3.24 liters. I know the mass is 5.03. I know the volume is 3.24 milliliters, and I'm trying to find the density. I can look up here. Door number 1 helps me find mass. Door number 2 helps me find volume. Door number 3 helps me find density. That's what I want to use. Density is mass divided by volume. Putting things in here, I get 5.03 grams divided by 3.24 milliliters. I divide that. I'm dividing by a smaller number, so I should get an answer greater than 1, which I do, 1.55, and it's grams / milliliters, which means grams per milliliter. Make sure your units are correct there. Let's go to another problem. We're going to flip the screen here. Let's see if we can do this efficiently. Okay, not bad. All right, let's take a look. What is the mass of a sample material that has a volume of 55.1 centimeters cubed and a density of 6.72 grams per centimeters cubed? So again, we have 2 numbers. We know 2 things. We don't know the mass. We do know the volume, 55.1 centimeters cubed. We do know the density, 6.72 grams per centimeters cubed. Okay, I go here. I'm trying to find volume. Volume equals... I'm trying to find mass, so I go to door number 1, mass equals density times volume. I look at that, I multiply the 6.72 grams per centimeters cubed times 55.1 centimeters cubed, giving me 370 grams. You notice I put a point there that has to do with significant figures. There's 3 figures here, 3 figures here. We'll get to that during the second week, so I wouldn't worry about all the rounding things at this point. We'll cover that in the second week. Just one thing to note with showing work, do you have to show all this? No. It's nice to show the units and how they cancel out. At a bare minimum, show me what you're multiplying or dividing. So in this case, that you're multiplying these 2 numbers to get your answer. Let's go to one more example here, and that will be... Looks like I'm having a harder time making the switch. I think we got it. This time we have a density of 8.24 grams per milliliter, and we have a mass of 0.451 grams, but we don't know the volume. Well, this is where I want to go to door number 2. Volume equals mass over density. I take the 0.451 grams, the 0.824 grams per milliliter. Notice how the grams cancel out, and the milliliters is in the denominator, but it's the denominator in a denominator, which makes it a numerator. So showing the units in the cancellation actually makes this work, and I get 0.547 milliliters for an answer here. Okay, just a quick little demonstration. We'll try to slide this over here, and I'm going to take this container, and yeah, I think you can see it there. And I have some Johnson's baby oil right here, which is mineral oil with a little stink or fragrance in there. And then I have some water with a little food coloring right here. And what I have here are, I don't know if you can see these things, probably not. I cut out a plastic milk carton. And then one of them I put in I just put a little red marker on so you can see it. So essentially I have high density polyethylene in a gallon milk jug. I'm going to drop that in here and let's see what happens. And let's see, I think I got a little surface tension at the top, so that might cause a bubble. I'm going to see if that stays there or if it sinks. Okay, this is kind of moving slow. I got a little air bubble in there. I'm going to try to knock that out. And it looks like it might be sinking. Now, what happens is things that are more dense will tend to sink. Things that are less dense tend to float. So what happens is the water is more dense than mineral oil. So the water is at the bottom, the mineral oil is on top. And oil and water don't mix, and that's why we get two layers. It looks like the high density polyethylene is somewhere in between that of water. It floats on the water, but it sinks in the mineral oil. Let's just look at something else real quick and think about water. I have two containers. I have 50 milliliters of water. It will have a certain mass. What if I double the volume to 100 milliliters? Okay, I will also double the mass. So doubling the volume, doubling the mass, but the ratio of mass to volume, which is the density, stays the same. And water actually has a density of 1.00 grams per milliliter. Okay, the baby oil has a density less than 1.00 grams per milliliter. I think it's about 0.87 grams per milliliter. And this high density polyethylene it's low density polyethylene probably has a density of maybe 0.92, 0.93, 0.94. So that's why it's in between those, it floats in the water and sinks right there. Okay, let's see. So there are some density problems in your homework packet. Try these. Check the homework keys for accuracy. Condensed notes for this video are posted, and ask questions if needed. Thank you.